Assalamu alaikum and good morning everyone. I am Mobin from CSIRO Land and Water. We are one of the Australian search partner for this project. Today on behalf of CSIRO team, I will provide a brief introduction to our work, which we will be building on our existing engagement in Pakistan for the Australian government funded Indus STIP project. For the STIP project during last 6 years, we had a great honor to collaborate with key federal and provincial agencies and educational institutions. It is great to see some of our partners are also attending this event. For the STIP project, together with our Pakistani partners, we have conducted integrated water sources assessment and produced a number of knowledge products. Among these, two notable products are Water Apportionment Accord tool, which brought the consistency and transparency in interprovincial water sharing processes. And the second product is Delhi Indus River System Model, designed to explore water food energy nexus for Pakistan. As highlighted in earlier presentations, secondary salinization in Pakistan is attributed to poor water management practices. In some areas, it is caused by the recharge from the irrigation network and irrigated field, causing waterlogging and salinity, and whereas in some areas, lack of surface supplies is forcing farmers to use the brackish groundwater, causing soil salinity and sodicity. Considering the strong linkages between the river and irrigation system operation with salinity, Pakistan National Water Policy has emphasized the need for basin-wide holistic approach to tackle this problem. For the Salinity project, building on STP work, we have conducted historical time series basin scale water accounting and identified the canal command where the groundwater use is becoming less sustainable. Based on this work, we have recently published a paper and some of the results are also presenting in the spatial map on the right side of this slide. Similar to water balance analysis, we are subject to the data availability. We will try to conduct the saltwater accounting as well to understand the salt accumulation in different parts of the Indus Basin. So based upon the groundwater trend analysis, we have identified Sidnai and Lower Melsi Canal in Punjab, where the groundwater tables are sharply declining, as well as we have selected a Baniari Canal in the Sindh, where the groundwater is shallow and causing waterlogging and salinity over there. For these selected areas, we will be doing a more detailed analysis using the multi-scale remote sensing images to understand the evaporation and irrigation performance trends over there. Using the Indus River System model, we will develop future outlook scenarios to understand the potential impact of climate change and the dam sedimentation on future water availability and future agricultural demand in the Indus Basin and associated implication for irrigated agriculture in Pakistan. Thank you very much. If something is not clear, myself and my team is happy to take further questions during the discussion session.
We are building on the outcomes and learnings from the ACIR project on improving groundwater management. We used loggers to understand changes in groundwater levels and salinity, and this helped us to improve our understanding of groundwater together with stakeholders. The farmers we worked with showed a keen interest in using EC meters to monitor groundwater used for irrigation as well as for potable use. So the groundwater project has helped us to improve our understanding of groundwater together with stakeholders. It's helped us build capacity to monitor and model groundwater. As part of the ASSIB project, we plan to map and model groundwater and salinity in selected canal commands of southern Punjab and the coastal areas of Sindh. Both locations are affected by salinity, but from very different sources and mechanisms. The southern Punjab districts of Lodharan and Vihari show some of the steepest declines in groundwater levels, and as a result, poor groundwater quality from the deeper parts of the aquifer is being used for irrigation. In the coastal areas of Sujabal, the salinity is of marine origin due to low land gradients and seawater intrusion from past and present incursions. Shallow water tables in this region are of major concern as marginal to brackish water tables affect plant growth and productivity. The groundwater models that we plan to develop will help us to understand water balance and climate change impacts on the availability of freshwater resources. Our previous work in the ACIR project, we selected the Malwa distributary in Shahid Benazirabad district as one of our bright spot communities to understand how they are adapting to salinity. Groundwater at the tail end of Malwa is marginal to saline and also relies more on groundwater for irrigation. So we need to understand how these communities are adapting to salinity in these areas. Thank you.
In this presentation, I will discuss about the plan for the knowledge management in the project. My name is Waqas Ahmed, representing Mehran University of Engineering Technology, Jamshoro. Traditionally, data generated through the research remain isolated, and it's difficult for larger audience to find and access the data. Data is generated into a project which is lost in private computers, and usually the report is published in a hard format which goes to the shelf and it's hard to search. The best practice is to standardize the data using international protocols, make sure that quality assurance and quality control is performed on the dataset. Metadata of each dataset is produced, and then data goes to a central repository. This repository should be on standard protocols that can be searchable via web portal or other search engines. What is the benefit of this? That if the data is stored in such a system, then knowledge products can be developed, such as weather apps, farm apps, or water requirement apps, water allocation apps. These kind of application, mobile-based application or software-based application can be developed. The key aim of the proposed web-based data portal for the ASSIB project are to share the produced data among the team during the execution of the project and to facilitate the delivery of the intended project outcomes. Second aim is to create a central platform for data storage related to the project with an associated portal through which data can be identified and accessed according to predefined rules and procedures. So there will be different data sets. First will be a primary data which will be produced in the project. Other will be a secondary data which we will acquire from the departments, and then there will be reports and publications. So what we will do is we will standardize all of the data sets into a standard data where the attributes will be such that they are internationally agreed and are searchable. We will do a quality assurance and quality control. Then we will put the data into a central repository. Then there will be an administration portal and end user portal which can communicate with the repository, and all of the information will be based on a web portal system for data visualization and data dissemination. Once all the system is in place, then what can happen is we can produce knowledge products for decision support, or we can do a reanalysis of the data, and that can again go into the central repository through all the standardization system. So this is the proposed approach which we are proposing for managing the data in this project. What will be the outcome of the project? One will be a website for the overall project. The second output will be a data sharing dashboard where we can share the data during the execution of the project. Third will be the standard schema-based geodatabase, which will hold all of the data which we will acquire in our primary collection or a secondary data sets, and all the reports which will be go into a standard schema-based database which can be searchable through web or other applications. We will also write pipeline script which will fetch the data from the database and can analyze the database according to the needs of the researcher. Thank you very much.